Okay. The next piece in similarity and proportions is parallel lines and proportional parts. So we'll start with proportionality of, or parallel lines here. Parallel lines cut through their transversals proportionally. So here we have three parallel lines cutting through the two transversals. Now, we're not saying that A, B, and D, E are congruent. They come from different transversals. We are saying that they are proportional. They are the corresponding parts. The pieces between the parallel lines are corresponding parts. So we can take AB and C and BC, AB and BC. So top piece over bottom piece. And then from the other transversal, we can match that with DE over EF. Top piece over the bottom piece. So again, this is all about corresponding parts, but instead of from two different triangles, it's from two different transversals. We cannot use, again, we cannot use these little pieces that just stick out at the top and the bottom. We don't know how they got cut off. We don't know if there's an invisible parallel line there. So you can't use the stray pieces. We can use the pieces between the parallel lines. We could even use the whole thing, AB, AC, and DF. But we need two sections from one transversal, two sections from the other transversal. So again, for example, I could say AB over AC. So the little piece that was blue over the whole thing. But I would match that from the other transversal with the corresponding parts. So DE over the whole thing, DF. Corresponding segments. So let's look at some of these proportions. AB and BC. That corresponds to EF and FG. They're the corresponding sections of those transversals. In the next fraction there, in the next proportion, we have AB and CD. So the top section and the bottom section, that corresponds to EF and GH, the top section over the bottom section from the second transversal. In our third example, BC over CD, that corresponds to FG over GH. And again, it doesn't have to be the small sections. For example, AB and BD, well, that corresponds to EF and FH. The corresponding parts are the things, but are the parts between the same parallel lines. So this could easily be AB over BD, EF over FH. Once you grasp the corresponding parts, setting up the proportion will be very simple for you. What if I said BC and AD? Well, that corresponds to FG and EH, the whole thing. So, for example, the middle section over the whole thing is proportional to the middle section over the whole thing. All about corresponding parts. So parallel lines cut their transversals proportionally. In the past, we have looked at this as two separate triangles. And it is a small triangle inside of a big triangle. However, we could say treat them like transversals. As long as they come to a point, remember, we can't use the little stray ends, but long as they come to a point to form a triangle, we can. So we can say AB over AC, or we can even do AB over BC. The top section over the bottom section, and that corresponds to the top section over the bottom section. So we could do left side of the small triangle over left side of the big triangle, right side of the small triangle over right side of the big triangle. Or we, in this picture, because they are triangles, we can treat them like transversals. And do top section over bottom section. And we will get the exact same results. Now, when it comes to the parallel lines, those you always have to do as if they're separate triangles. This is only for the sides, the transversal sides. The parallel lines always get worked out as separate triangles. This is just a reminder about a midsegment. Because it's a parallel line in that triangle, this is just a reminder about midsegments from our special segments unit. So there's nothing new in this slide. It's just a reminder because we're talking about parallel lines. The other thing here is that in a triangle, an angle bisector cuts the triangle proportionally. So if this is our angle bisector, we're going to do on the left side of the triangle, the two segments are proportional to the two segments on the right side of the triangle. So AB and BD, the left side of the triangle is proportional to the right side of the triangle. AC and DC. An angle bisector cuts the triangle so that the two segments on the left are proportional to the two segments on the right. It almost sets itself up. If we look at this first Here's our bisector, our angle bisector. Here's our two fractions. 18 over 10, 30 over x. 18x, 300, and then we'll divide 300 divided by 18, and we get 16.7. The side 18 is smaller than the side 30. So the portion 10 is smaller than the portion 16.7. Looking at another example, again, the angle bisector splits the triangle, so the two segments on the left are proportional to the two segments on the right. So here's the problem. We don't know this segment. We can fill in everything else so far, but we're missing that segment right there. We need something to put there. Well, we might have to do a little figuring out. In this case, the entire segment is 60. So this is 60, not including the part that's labeled X. So the whole thing is 60. Part of it is X. We want the part that's left over. Well, it's the whole thing, the 60, not including, so minus, the part that says X. That's what we're going to put there, 60 minus X. The whole thing is 60. Part of it is X. We don't want that part, so subtract it, 60 minus X. And now we're left with the piece we need, BD. And at that point, we're going to cross multiply. So I'm just going to bring the work up here. 24x equals 40 times 60 minus x. Make sure that you treat that expression like it's in parentheses, so we distribute correctly. For x, 240, 240 divided by 64. Not 240, 2400. Big difference. I am having some challenges here. 2400. 37.5. So x is 37.5. 60 minus x tells us that the left side is 22.5. And again, the left side is smaller than the right side, so the left segment, BD, is smaller than the right segment, DC. So we can see some consistency in these values. Okay. All right, parallel lines and proportional parts.